Welcome and thanks for joining today's presentation on improving water quality at Rock Creek and other parks in the DC area. My name is Brian Fainer and I'm with the National Park Service and help support the NPS's Connected Conservation effort. The Connected Conservation webinar series focuses on how NPS staff and partners use various tools and strategies to conserve NPS resources at the landscape level. We host a webinar at least once a month, and you can find recordings of past webinars on our internal Connected Conservation Toolkit and the Network for Landscape Conservation website. And I'll be adding links to both of those websites into the chat box here shortly. We will post today's webinar following the presentation, and throughout the presentation, feel free to plug in questions into the questions box. We'll take a look at everyone's questions following the presentation. Today we have four excellent presenters with us. Cecilia Lane is the Environmental Protection Specialist for the DC Department of Energy and Environment, where she manages large-scale restoration projects around the district. She's been working on environmental policy and restoration for the past 10 years. And prior to joining the Department of Energy and Environment, or DOEE, Cecilia worked as a stormwater coordinator for the Chesapeake Stormwater Network. Stephen Reiling is the environmental engineer at DOEE and is responsible for planning and implementing watershed protection projects that include stream restoration, green roofs, low impact development, and other strategies to lessen the harmful impact of stormwater on the district's waterway. Then we have Seth Shard, is the Green Infrastructure Manager in DC Water. Seth has been implementing DC Water's Green Infrastructure Program for combined sewer overflow control under the DC Clean Rivers Project since 2013. Seth holds an MBA from the University of Maryland and an MA in Sustainable Land Use Planning and Design from the Conway School. Finally, Carlton Ray is the director of DC Water's Clean Rivers Project and has more than 30 years of engineering and leadership experience in both public and private civil engineering sectors. Carlton is responsible for implementing DC Water's 20-year, $2.7 billion federally mandated consent decree to control combined sewer overflows. And before we get started, I also wanted to point out and let everyone know that Nick Bartolomeo, who is the Chief of Resource Management at Rock Creek Park, is also joining us today from the DC Department, from DOEE's office. And Nick, did you want to say a few words?
Yeah, thanks a lot, Brian. Hi, everyone. I'm really glad to have you here today to learn about these stormwater management projects in DC. These projects are going to bring substantial benefits not only to Rock Creek and Rock Creek Park, but also to the Potomac and Anacostia rivers, as well as those parks that border these waterways, such as National Capital Parks East, Chesapeake and Ohio Canal National Historic Park, the National Mall and Memorial Parks, and the George Washington Memorial Parkway. There are no doubt challenges to undertaking these projects, including securing funding and complex project planning, and most importantly, maintenance of what is constructed. But these are minor when compared to the benefits brought about by these projects, which are important examples of what can be accomplished when government agencies work patiently and cooperatively together. I hope you find these projects inspiring and that we look forward to answering any questions you may have.
Great, thanks, Nick. So with that, Cecilia, Stephen, Seth, and Carlton, the floor is yours.
Great. Thank you so much, Brian. As mentioned, my name is Cecilia Lane, and I'm an Environmental Protection Specialist at DOEE, and I'm here to talk about some of the ways that the district restores the waterways in the district. So we primarily focused on Rock Creek for this presentation, but we do work all over federal lands within the district. And hopefully I can get my PowerPoint to work. Okay, so just very briefly, I've put together an agenda. I figure we'll give a brief introduction. Not sure how many stormwater management professionals are on the line. I'm sure people are more experienced with stormwater than they realize if you're a land manager. We'll talk a little bit about background issues, like the problem of stormwater management, the so what, why do we care, and how stormwater is a little bit different in the district. And then we'll talk about the different approaches that we take to restoration. And DC Water and DOEE were two separate agencies, and we take different approaches as a result. So a little bit on the background of stormwater management. Why do we do what we do? So prior to developing the land, as you can see in the schematic on the left of your screen, we had lots of vegetation, we didn't have any impervious cover, and we had really good soils that would act like a sponge. When rainwater fell on the land, a lot of that was used by the vegetation. What wasn't would soak into the spongy-like soils and be filtered and cleaned up and then ultimately returned to our streams and rivers, because we do need a source of water for our streams and rivers. As you can see on the schematic on the right-hand side of your screen, some of the things that happened after we developed the land. So we cut down the vegetation, we graded and compacted those soils so they no longer have that sponge-like quality. We added a lot of structures, impervious structures that rainwater cannot penetrate through. Things that we need, things like homes, driveways, roads, schools, other buildings. And what that results in is a whole lot more stormwater running off of the land. So what we talk about here is stormwater runoff, so the amount of water running across the land. So you can see in the schematic on your left the difference in the size of the arrows between the surface runoff coming off the land in pre-development conditions, and then again on the right, the amount of runoff coming off the land in post-development conditions. Okay, so what? So why do we care? Well, here's the problem with stormwater runoff. When we have more volumes, you can see, I'm sure many people are very familiar with flooding issues that we experience. In DC, we experienced not that long ago. We had a really big 3-inch storm in July that flooded out Canal Road and made national headlines. In addition, when stormwater runs across the land, it picks up whatever pollutants or other things that are on the land, things like fertilizer, dog waste, trash, heavy metals, grease, and other pollutants. Finally, when we take stormwater, we put it into a pipe and then we put it into our streams and rivers. It comes out, we're putting more quantity, it's coming out faster, it's coming out hotter, and it's coming out like a fire hose. In the picture in the upper right-hand corner, you can see what we call outfalls, stormwater outfalls. This is where stormwater comes from the street into our streams. Those outfalls actually used to be at the same elevation as the stream bed. But you can see after so much time how much erosion occurs. All that sediment is moving down into the streams, impacting the aquatic habitat. And then, as I mentioned in the lower right, this is what, unfortunately, a lot of our streams in the district look like. We have tons of trash, plastic bags, plastic bottles, anything else that's on the land is picked up and channeled right into our streams. So the the field of stormwater management is trying to capture that stormwater, slow it down, clean it up, spread it out, and improve water quality downstream. So before I go on, the one thing that we like to say is that stormwater really is a land use issue, and Stephen Reiling is going to talk a little bit about that.
Sure. Thanks, Cecilia. Again, I'm Stephen Reiling, an environmental engineer with DOEE. And here's just a brief slide to show you why stormwater is an issue. This shows the impervious surface in the District of Columbia. This slide's several years old. I don't know if we've gained more impervious or if it's been mostly redevelopment, but regardless, you can see the impervious area of the district is nearly half of the land area of the District of Columbia. And why is that an issue? I think Cecilia touched on it a bit, but wherever there's impervious surfaces, the water can't infiltrate into the ground, recharge the groundwater. It runs directly off the roads, roofs, and other impervious surfaces into these stormwater outfalls and then directly into our waterways, causing erosion, transporting oil, grease, trash, and other pollutants to the streams.
And so this amount of land use and this amount of impervious cover means that a single 1.2-inch storm event, which is the standard that we use in the district, we're trying to capture the first 1.2 inches. That's considered the first flush in stormwater management, meaning that the majority of those pollutants are going to be held in that 1.2-inch event. Will produce about 525 million gallons of stormwater runoff that we're trying to capture and mitigate the impacts from. So how do we do this? How does DC restore our streams and rivers, our watersheds, and stormwater? Well, we're going to talk two different approaches today. We're going to hear from DC Water, and then we're going to talk a little bit about what we do at DOEE. But before we do that, I just wanted to briefly go over the fact that the district has a little bit of a different situation with our drainage areas. We have two main sewer sheds, and Carlton's going to get into this in a lot more detail. So I'm just giving a very big overview, but two main sewer sheds. We've got what we call the CSS area, or the combined sewer area, and DC Water focuses their efforts there. And then the MS4 area, or the municipal separate storm sewer system. That's why we call it the MS4 instead, and that's where DOEE focuses our efforts. So again, you're going to see this slide a couple times over the course of this webcast, but just wanted to briefly draw that to your attention. So with that, Brian, I'd like to hand the slideshow over to DC Water for them to talk about their approaches to restoration.
Thank you, Cecilia. This is Carlton Ray, and Director of the DC Clean Rivers Project. And we should be on, let's go to the next slide, please, slide 9. So there's a couple diagrams in the upper right-hand corner of that slide. The top diagram is the separate storm sewer system and sanitary sewer system that are separated, that Cecilia was talking about. The gray area on the left-hand side of the page there, those are all separate, or the municipal separate storm sewer system, or MS4 area. But that diagram shows you that basically the water coming off the street goes through the storm drain and out to the Anacostia, Potomac, or into Rock Creek. The sanitary sewage that comes out of that clay building goes into a specific sanitary sewer that flows down, ultimately down to Blue Plains and gets properly treated. So that's, again, and most of that sewer system was constructed after 1900. But before, in the 1800s, late 1700s and 1800s, Cecilia referenced that the combined sewer area, or that green blob in the middle of the district boundaries there, it's known as combined sewer area. And if you look to the diagram just to the right of that, basically you see the sewage that's coming out of the clay-looking building. This is a lower level drawings there, schematic. Goes into the same pipe as the pipe, or as the water that comes off the street. And during dry weather, no problems. All the flow goes down, hits a weir, and it ultimately flows down to Blue Plains, gets properly treated. But during wet weather, and when it rains, that one single pipe in the street that serves like the White House, the Capitol, older parts of the town that were constructed again in the 1800s, there are actually physical pipes that were built in the 1800s, or the yellow dots on the left-hand side of the page there in that schematic again, are physical pipes that can be 8, 10, 12 feet in diameter that allows raw sewage, combined sewage, to overflow into the Anacostia, Potomac, and Rock Creek. This has been going on for 150 plus years, a number of years, and 750 other communities across the country have the same combined sewer system, type of combined sewer system. New York, Boston, Chicago, Indianapolis, Seattle, Portland. A number of communities have these combined sewers that were constructed, or at least they were developed about that time period. And on the next slide, we see a series. What's wrong with combined sewage flowing into? Well, anything that's in sewage, okay, you guys can picture that, can end up in the river. And so 75 to 80 times a year, we'd have these overflows occurring, and you can see on the left-hand side there, the series of slides there, of the amount of debris and other things that can flow into the river, and has flown into the river. Also, we have a storm sewer system that was built was built by the federal government a number of years back. They were undersized, and so we have significant flooding problems up in the northeast side of town. So the program that Seth and I are going to talk about today, the Clean Rivers Project, addresses these two main issues. One is the combined sewer problem, and then the other one is the flooding problem. So the purpose of our program, again, is to address the combined sewers go to the next slide, to Potomac River, Anacostia, Rock Creek, as well as relieve the flooding in the area up on the northeast part of the district. because this is a violation, the sewage violated the Clean Water Act, there was a federal consent decree that was issued and agreed to by U.S. EPA, Department of Justice, the District of Columbia, and DC Water. And that plan, we have a plan, I'll show you in a second, it's under a federal consent decree, and it's going to be completed by March of 2030. We're currently on schedule, on budget, and met all the milestones to date. On the next slide, you can see on what was originally proposed back in the late 90s, and how because of more knowledge and kind of an evolution of knowledge and goals by the community, we've modified the consent decree, and that was modified in 2016 to include the diagram on the right. And we can go to the next slide. It really gets into showing that. So basically, if you can remember those yellow dots on that first slide that I showed you that showed the locations of the combined sewer overflows, we have to go there to pick those up. Instead of allowing raw sewage to dump into the river, we're building a tunnel system that's larger than a metro tunnel. So if you've been on the metro here in DC, most of those are 18, 19 foot in diameter. We're actually constructing larger tunnels, 23 foot in diameter, and we go underneath the metro tunnels. And we're building a series of tunnels, approximately 18 miles long, to capture sewage that otherwise would end up in the Anacostia or Potomac River. That would flow by gravity, drops to 100 to 160 feet down to this new tunnel system that we're constructing, flows by gravity to the world's largest advanced wastewater treatment system, a cool place to come tour if you ever get a chance to come to DC and want to tour a place, cool thing. Blue Plains is a great place to tour, lots of cool things going on here. We pump that flow up and then maximize and treat the water, and it looks like Colorado Mountain spring water once we get finished recycling the water. It's really a good looking product. Also, you can see those green blobs up in Rock Creek, as well as over in the Potomac River on the schematic. That's areas of green infrastructure. And Seth is going to talk to you a little bit about the green infrastructure we're building in those areas, and basically building that green infrastructure to reduce the combined sewer overflows in those areas. Ultimately, when we build this system, we're going, it was determined back in 2003, if we build this system, we'll do post-construction monitoring, we will ultimately meet water quality standards and take this giant source of pollution off the table that's been going on since the 1800s. And you can see kind of the projections here on the left-hand side, where we're going to ultimately go down to capture 98% of the sewage that's going into the Anacostia, and overall 96%. If you go to slide 15, this is we brought the first phase of the tunnel. I'm sorry, let's go back to the previous slide. The previous slide shows the tunnel that we've constructed to date. The pink part is the 7 miles of tunnel that we've constructed down here at the Blue Plains. We've constructed that, as well as up in the northeast part of the district of what we call First Street Tunnel. All that's constructed and was brought online in March of last year. So we go to the next slide. We had a very, very wet year. We had 66 inches of rain, it's the wettest year on record. We captured, with that first 7 miles of tunnel, not 6 million, but 6 billion gallons of sewage, and really exceeded our capture rate. We were estimating this first phase, we're targeting 80%. We're actually targeting 90%, capture 90% of the sewage. We've also caught 2,500 tons of trash. A good bit of it's organic material, but a large percentage that Cecilia was talking about is those bags that you normally see in our rivers and streams. That number of those came from our CSOs, and people drop them into the combined sewers or on the streets that flowed in off the streets into the sewers, ended up in the rivers. We've captured that, and now we're getting that out of the rivers. It's amazing success story. So we had basically Anacostia River was focused on initially because 2/3 of the sewage was overflowing into the Anacostia. About 1/3 of the sewage overflowed into Potomac, and then a relatively small amount overflowed in Rock Creek. So we focused on the Anacostia first. The Anacostia Watershed Society had a nice report they did last year. You can see kind of the tick list of things, but it was basically people were excited and to see a dramatic improvement with much less debris that was in the stream segments that people used to experience, the boaters used to experience. We're just getting this is our first phase, but we're already seeing substantial improvements with our program. The next phase we're currently constructing is that second phase in the Anacostia, which is the northeast boundary tunnel. That's a 23-foot diameter tunnel, again, about 5.5 miles long. Pretty good amount of money. It's $580 million, of which majority of it's being paid by district ratepayers. And so we're blessed with some wonderful district residents who understand and the benefits we're providing. So we're very, very thankful for our ratepayers. That will be completed in summer of 2023, and then that will meet or exceed the 98% capture with the combined sewage on the Anacostia River. So ultimately, we will meet with the CSO program. We'll meet the fishable and swimmable goals for this program. There's still some work that's got to be done by Cecilia's group and fine folks in Maryland, but this large source of pollution that's been going on since the 1800s will be finally addressed. You can just see a nice picture of the kids on the river. We encourage folks to come to the river. It's a great river, just like the Potomac and Rock Creek. It's just a wonderful, wonderful place. We have the Anacostia National Park Service National Park Service has a wonderful park, and we're just making it better with the debris removal, and as well as all the sewage that we're taking out of the river. So I'd like to turn it over to Seth, who's now going to talk about what is green infrastructure and how is that being addressed by the DC Clean Rivers program and DC Water. Seth.
All right, thank you, Carlton. Again, this is Seth Chard, the Green Infrastructure Manager with the Clean Rivers Project. And so we'll talk a bit about what we're doing on the program with green infrastructure. But first and foremost, what is green infrastructure? Many of you may already be familiar with these technologies, but just to give a brief overview, the green infrastructure basically uses processes that mimic natural water processes. So kind of going back to Cecilia's slide about the pre-development and post-development conditions in the district, green infrastructure can mimic those pre-development conditions when it's raining. It filters, it cools, and slowly infiltrates water back into the ground and encourages evapotranspiration. So really sort of recreating or mimicking those natural processes. And when you apply it to combined sewer overflow problem, we can start to solve that problem by holding that water back in the green infrastructure facilities, keeping it out of the combined sewer pipe in the street. You build enough of that green infrastructure, you prevent the overflow downstream. On the bottom of the slide, we just show a couple examples of what green infrastructure looks like. So it includes things like rain gardens and bioretention, downspout disconnection and rain barrels or rainwater harvesting, green roofs, and permeable pavements. So specifically on the Clean Rivers Project, we've in the past year, we've actually completed our first two large-scale green infrastructure projects. One on the Potomac sewer shed. It's the first of 3 contracts under the consent decree, and we, under that project, managed 44 of 133 impervious acres at that 1.2-inch storm standard. And we started construction in spring of 2018 and completed just in spring of this year, 2019. And you can see sort of the mix of Facility types, we use planter bioretention, curb extension bioretention, parking lane permeable pavement, and alley permeable pavement. Those are the green infrastructure facility types that we utilized on the Potomac River Project A. On the Rock Creek side, we completed the first of 5 contracts under the consent decree. And on that project, we managed 20 out of the 365 impervious acres to that 1.2-inch storm standard. We started construction in 2017 and completed construction in 2019. And again, you can see the mix of facility types, the same types of facilities, the planter bioretention, curb extension bioretention, parking lane permeable pavement, and alley permeable pavement. Moving on to the next slide, under the terms of the consent decree, the way it's structured is we have 3 projects on the Potomac side and 5 projects on the Rock Creek side. And after each of those projects, we conduct a practicability assessment to make sure that the facilities are functioning as intended, as designed, and we can do it in a cost-effective manner. So in terms of where we are today, moving over to the diagram on the right, the flow diagram, we've constructed those first green infrastructure projects, and now we are in a post-construction monitoring period where we actually have flow meters down in the sewer network, and we're looking at the pre- and post-construction performance of that green infrastructure after we've built it. Later in, mid-2020, we will complete a report that goes back to the EPA, which makes a recommendation or determination of whether green infrastructure is practicable, in which case we will continue with our program, or if it's shown to not be performing as designed, or if we can't be cost effective, then there's this potential off-ramp to go back to the gray infrastructure solution with a longer tunnel on the Potomac side and a smaller storage facility on the Rock Creek side. But back to green infrastructure, and again, the types of green infrastructure that we're implementing under our program, most of what we're doing is out in the public right-of-way. So, out in the street, in the parking lane, in that planting strip between the parking lane and the sidewalk, or back in the alleyways. And so this slide just shows a few of those examples with cross sections. Essentially, all of these facilities, you're excavating out and down about 4 or 5 feet. You're backfilling with gravels to store the water. And then in the case of bioretention, you're placing a very sandy soil on top of that gravel and then planting out the surface. In the case of permeable alleys or permeable parking lanes, instead of that bioretention soil, you're continuing up with the gravels and then putting a permeable pavement surface on top of that alley or parking lane, be it asphalt or concrete or a precast concrete paver. And we have a few pictures that show both the construction of these facilities and the finished product. And so this permeable alley slide shows sort of the sequence of construction where we go in, we build this edge restraint. That's the picture on the upper left corner. We excavate out and we place the gravels. That's the picture on the upper right corner. And then we start placing these pavers, laying them down on top of that gravel. And the pavers actually have a gap in between them so that when water flows across the surface, it can flow down in and get down into the subsurface storage layer. And then finally, the picture on the lower right-hand corner is the finished alley. Looking at the parking lane, it's very similar in terms of the construction approach as the alley. Really, the only difference on the parking lane is that the surface course is a porous asphalt instead of a precast concrete paver. And that porous asphalt essentially has fewer fines in the mix, and so you end up with more void space in the surface. And essentially, those void spaces allow for rainwater to flow through them, and again, get down into that gravel storage layer. Just one difference on this sequence of photos is if you see in the upper left corner, you can see the full excavation. We've lined this facility to protect the structural integrity of the roadway. And in that excavation, you can see some of the gravels that have been placed, and then a subsurface check dam, which helps us manage the water and the slope that might exist underneath that facility. Moving on to the bioretention. Most of these bioretention are constructed within the planter strip. We do have a few curb extension bioretention, but essentially we excavate, we build the formwork for the concrete, we build some concrete walls, and then backfill with those gravels, soils, and then plant it out, and you can see the finished result on the far right-hand side. And then this slide, just showing again the finished product for the parking lane, the alley, the planter bioretention, and the curb extension bioretention. And in fact, the upper left-hand corner is the ribbon cutting with the mayor, the council member, and our former GM, George Hawkins, where they're pouring water onto that surface, and it's getting taken right down immediately down into that subsurface storage layer. Another part of our program is a downspout disconnection. And so within the green infrastructure areas that were identified on those maps, essentially we're going out and going door to door and talking with neighbors and disconnecting downspouts that were previously connected directly to the combined sewer system. By disconnecting that downspout, extending it out and directing that flow across someone's yard or into their landscaped area, you can provide irrigation, but then we're also removing that volume out of the combined sewer system, and again, helping to prevent that overflow downstream. Slide 21 just has some of the statistics of how many homes we've been to, how many disconnections, but essentially, as of 2019 progress, we've disconnected the equivalent during a 1.2-inch storm, the equivalent of almost 40,000 gallons. And we do that work in partnership with the Rock Creek Conservancy, and they also have been hiring graduates out of our National Green Infrastructure Certification Program, which we have been using as a workforce development and targeting local residents and helping connect local residents with jobs within our green infrastructure program. And so where does that lead us? Well, again, the green infrastructure area on the Rock Creek side, that subsurface sewer network would otherwise all lead out to CSO 49, into Piney Branch, and then out into the Rock Creek Park. And so by building more green infrastructure, doing these downspout disconnections, we can reduce those combined sewer overflows and keep that mix of raw sewage and stormwater out of Rock Creek Park, enhancing the enjoyment for residents and visitors within the park itself. And then finally, just looking at a few examples of other projects that DC Water has partnered with DOEE and in some cases with National Park Service. We have a couple examples here. So Soapstone Valley Sewer Rehabilitation. The Soapstone Valley is a really beautiful side branch off of Rock Creek Park. There's a beautiful trail and creek that runs through it. Unfortunately, there was also a pretty severely degraded sewer pipe within that valley. And so we partnered with DOEE and NPS to make some improvements, and we'll talk a little bit about what we did there. And then the other one is Spring Valley. And so that was a DOEE-led project where we were able to partner with them and do some improvements to the sewer pipe to repair and protect that pipe. So specifically on Soapstone Valley, we will repair or replace and rehabilitate approximately 6,200 linear feet of sanitary sewer. Again, repairing and replacing a number of sanitary manholes, also stormwater outfalls, and protect the sewer infrastructure, which in some cases the stream bank has eroded away, and you can see some of that in the pictures on the right. And of course, all of this is to protect the park and enhance recreation and enjoyment and the ecological function of the park. Moving on to Spring Valley, this was essentially a DOEE-led stream restoration project, but we identified a sewer pipe that was in need of rehabilitation. And so partnering with DOEE, we were able to work under their permit and do the repairs to the sewer pipe and get that repair done in a much more streamlined fashion than if we had gone on our own to do that. And then finally, I'll turn it back over to Carlton to talk about a National Park Service DC Water partnership.
So one thing is when you have a big program like DC Clean Rivers Project, when we interact with National Park Service, like Nick was talking about, there's multiple groups and people that we interact with the National Park Service. So it was helpful for us to have one person that we can be as someone as a liaison. And so we actually hired this person through the National Park Service and through a project agreement to help us facilitate communication, because that's the word. We must communicate what's going on, what's going to happen. And so it's been it helps facilitate reviewing permits, construction issues, and helps basically address the things that if we're having to deal with multiple folks at different times, it'd be a little more difficult for us. And so that's worked out extremely well. We've had that agreement for a number of years, and we're pleased. It continues to happen today. It's just a great service. I thought just for the folks on the phone might be interested in knowing that something like that does exist. So I'll turn it over to Cecilia and Stephen now. Thank you.
Thank you, DC Water. That was an excellent overview of the gray infrastructure upgrades that are going on, as well as the green infrastructure upgrades that you all are doing. Can you see my screen?
Yes.
Okay. You're seeing a DC Water slide, unfortunately, though. Hang on, everybody. We're going to go fast forward through this real quick. Little recap of what we just learned. Okay, so now we're going to talk a little bit about how the District Department of Energy and Environment, DOEE, handles our restoration approaches. Again, we're going to remind you that there's two different sections of the district when it comes to drainage. We've got the CSS where those tunnels are going in to capture a lot of that, and the MS4 area where there is no treatment of that stormwater. It goes into the drain, it goes into a pipe, and it goes straight into our streams and brings everything that it picked up along the way with it. Again, we focus our efforts in the MS4 because we assume that DC Water's efforts with the tunnels is pretty much taking care of the stormwater pollution problem in the CSS area. So again, looking at the green portion of the district is where we focus our efforts. And we love working. We don't own any land in the district, so we have to work with partners. And one of our best partners are our federal partners, National Park Service. So how do we handle restoration? Well, we've got basically three main avenues. We've got a regulatory hook. We have stormwater regulations. So for any new development and any redevelopment that breaches a certain threshold, people must do stormwater management as part of those projects. We have direct public investment, which is, we're going to talk about two different case studies in a little bit about how we actually invest in these restoration projects. And then we have voluntary retrofits, either through financial incentives or disincentives. Some of our incentive programs include a stormwater retention credit trading program. So this is a way to, a cap and trade kind of program on an open market. So if someone overbuilds and does more stormwater management and someone else can't, they can actually buy those credits in an open marketplace. And then we have these incentive programs, such as River Smart Homes. Do you live in the district? You could be eligible to participate in the River Smart Homes program. Everybody contributes to the problem of stormwater management. Your home, your driveway, your yard, everything contributes. So we'd like to see a lot of that stormwater kept on site, reduced on site through different mechanisms. We also retrofit schools, some houses of faith, and we have a green roof rebate program. So if you are going to if you feel like putting a green roof on your parcel, on your property, we will subsidize a portion of that because we'd like to see that stormwater kept on site. Now, I'm going to talk about a case study of a larger retrofit project that we did on National Park Service land in the Rock Creek Park. We do both upstream restoration efforts, which is what I focus on, and downstream restoration efforts is what Stephen focuses on, and he'll talk about that in just a moment. So the one I want to talk about is the Carter Barron Stormwater Retrofit Project. So a little bit of background information. This is actually in the headwater streams, or what we suspect are the headwater streams of the Blagden Run watershed, which is about 240 acres. And averages 69% impervious cover. Remember earlier when we were talking about how stormwater is really an issue of land use and really imperviousness? Well, that's a huge percentage. The literature shows that you see degradation to water quality for aquatic life at 12% impervious cover within the watershed. And so we're looking at 69%. So you can imagine the impacts downstream. The Rock Creek Tennis Center, where we focused, or Carter Barron, is an 11-acre site, which contains about 15% of the impervious cover within that watershed. So large impervious area that was developed prior to any stormwater management regulations. So there are lots of opportunities on the site. We'll talk about how the stormwater leaves the site in just a minute. That graphic demonstrates the old watershed. So existing conditions, or conditions prior to this project, we had a lot of impervious cover that was relatively unused. There were probably a handful of events that happen there every year that fills up that parking lot. But so the parking lot is necessary, but it's not used all of the time to capacity. So lots of opportunities to capture and slow down that stormwater. You can see we're kind of at the top of the watershed, so water kind of leaves the site, goes through some outfalls, where at the time we thought we just discharged it to wooded areas, but what ended up happening was a lot of gullies were formed as a result. And this is truly a great example of partnership, because this project was brought to our attention by U.S. Fish and Wildlife Service, who had been doing some sampling and determined that this area potentially had some important species for us to protect. And they came to Rock Creek Park Service and they said, hey, we would really like to see you do something about these gullies that are eroding, because the sediment could impact the downstream habitat. So Park Service came to DOEE and said, can you help us with these gullies? And we said, wow, look at all this imperviousness and all of this adjacent open space. We can do a lot more than just stabilize these gullies. We can do a lot to clean up the downstream conditions. So stormwater used to leave the site through 5 outfalls. And now I'm going to just take you very quickly through, in the interest of time, very quickly through some before and after pictures of the project. So here on your left, we've got before pictures. You can see we've got a nice big open space through the trees. And what we try to do in stormwater management is capture that stormwater coming off of impervious and bring it into a space that's relatively unused and can handle some of those practices that Seth was referencing, like the bioretention or the permeable pavement. So you can see on the left, we had a really big open space, but we had to get through some trees, and this is right adjacent to a parking lot, that parking lot I showed you earlier. And you can see afterwards how we created some of these bioretention cells. But we had the challenge of how do we get that stormwater from the parking lot to the area that's open, and because we do have to get through trees. And one of the things we heard from Park Service as part of this project is we don't want to lose any trees, we don't want to have any negative impacts to trees. So you can see we had to do some creative design to get that water to come in through an inlet channel and wind its way through the trees. And this is just another photo of the practice from a different angle, a little bit more recently, so you can see some of the vegetation that's starting to grow up. And this is a water quality function, or water quality practice that's going to treat water. So again, here's that parking lot before, so lots of unused impervious cover, and then after, or during construction of the bioretention. So now water is actually going to go into the bioretention and slow down and filter. And you can see we didn't really lose that many parking spaces. We did have to shorten to some of these to compact cars, but didn't lose too many parking spaces. So again, before and after, and before and after. And the point of these photos is to really show you that what we're looking for when it comes to stormwater management are opportunities where A, the water is already going, B, we're trying not to impact the existing use of the site. So in the lower left, you can see this is an area of turf. It was previously an area of turf that was just managed turf. It wasn't necessarily used for anything. It doesn't have a dedicated function. And so now we can make it a stormwater feature without having any negative impacts, which is also going to not only improve water quality, but also improve habitat with the different vegetation other than turf. So here's another interesting photo from this project. Water originally ran along that curb line into a storm drain and went into the pipes and went straight into the streams, like we discussed earlier. But look at all those trees just on the other side of the curb line. Wouldn't they love to have some of the additional water? So this is a very basic, straightforward approach. We use something called a level spreader. So we allowed that water to be disconnected from that parking lot. We took it from the parking lot and put it into the wooded area so that before it went into the storm drain. Very, very straightforward, feed the trees or water the trees. Here's another area where we've got right-of-way along the roadway coming into the site. You can see there's an impervious pathway to the right, on the right-hand side, and which goes around an athletic field. And it's a heavily used pathway and a heavily used athletic field. But this strip of managed turf is nothing more than managed turf. So how can we make this an actual stormwater feature? Well, we can bring the water in and do that engineered filter media mix that Seth was referencing and build a bioretention. These are, again, not the best photos because they were taken shortly after construction, but you can even see in this one, which is more recent, not only does this have a water quality benefit, it's aesthetically more pleasing. Once we get the signs up, it'll be an education and outreach opportunity to all those people using that walking path. And finally, we're creating habitat for pollinators and other important members of our community. So very briefly, going kind of over the highlights of this project, I only showed you a few examples. Basically, we were able to do 8 formal, what we call BMPs, or best management practices. So those are the pictures I was just showing you. We did 7 gully stabilizations as a part of this project, and something called a subsoil application, which is a deep tilling approach to reduce compaction, improve infiltration, and restore the hydraulic functionality of soils. Because one of the things we are learning more and more is it's not just the impervious that's generating stormwater runoff volumes, but it's also the managed turf areas, since they are pretty compacted. We just won a NIFWIF grant on that, so more to come. Stay tuned. Oh, and we've also built a pollinator garden per Park Services request, since they love the pollinators. So really quickly at project benefits, obviously there's a stormwater function to all of these. But habitat protection, enhancement, and creation, not just a creation upstream, but the protection for the downstream critters that we talked about. There are air quality and urban heat island benefits to all green infrastructure. We did build a community amenity, and obviously, like we said, educational opportunities. I would be remiss if I didn't say that this won the Best Urban BMP in the Bay Award, which is a stormwater contest, a little contest for stormwater nerds. It was the best retrofit in 2019. Thank you very much. I'll take that. But the highlights are, and these are the preliminary results, but this project effectively manages 30,000 cubic feet of stormwater runoff, about 16 acres of land. You heard a lot of us talk in acres and how many acres we're actually managing. And then our annual load reductions of about 5 pounds of total nitrogen, 120 pounds, almost 120 pounds of total phosphorus, and 6,000 pounds of sediments that are reduced and kept out of our waterways on an annual basis. And those numbers are really important for us because we have something called an MS4 permit where we have to meet those load reductions, so we can count that towards meeting our permit requirements. And they're also really important towards the cleaning up the Chesapeake Bay. And so with that, I think I'd like to hand it over to Stephen to talk about some of the downstream options.
Yeah, hi guys, it's Stephen again. And in the interest of time, I want to leave like probably 5 to 7 minutes for questions. And most of my slides are just ugly and pretty pictures, kind of before and after. So this is our Milkhouse Forge stream restoration. This was, I think, the first collaborative project we had with National Park Service and Rock Creek Park. It's similar to Soapstone. There was some exposed sewer. You see some pictures of that. This was completed in 2011, and it was also my chance to first meet Nick Bartolomeo and Bill Yeaman. So I've known them since about 2011 and still have a great relationship with them. So here's some quick background. I'll let you read most of it, but it's 36-acre drainage area. There's 2 tributaries that come in. And this is, if people are familiar with the district, this is by St. John's College High School off Oregon Avenue. And you can see on the right part of the picture how these two tribs came in, went to Milkhouse Run, like the main stem of it, and then that went directly into Rock Creek itself. So I think that's really all I need to say about that. You'll see most of this is photos, and it'll give you a sense of what the project completed. So that's a picture of me back in 2011, standing on this exposed sewer line, a DC water line. Again, we worked closely with DC Water on this project as well. On the right, the gentleman looking at that pipe is a DC Water engineer who was inspecting this pipe before we completed the project. It was leaking a bit, so we repaired that before we performed the restoration. And just keep a look at that manhole. You can see how exposed it is, and you'll see some other photos in the after that We'll show how high the original stream bank used to be. This is probably complete, the sewer work we think was probably done in the 60s. So you can see usually sewer lines have a couple feet of cover over them. So you can see how much the stream or tributary was degraded over the last 40 to 50 years. To do this, we used we had it designed and constructed by consultants, and they used a technique called a regenerative stream conveyance, which is basically just mimics a natural stream, and you have a pool and riffle system to transport the stormwater through the system. It dissipates energy. It's able to infiltrate. You can see where it says seepage. There's water that replenishes the groundwater table. And in some cases, we've seen dramatic rises in the groundwater, in the order of 10 feet or so within a week or a month. I mean, it really impacts the groundwater in a positive way quickly. So here again is that manhole that I showed you. That you can see the sewer line that's just kind of hanging there. I was able to, I could crawl under that. And then you can see the after. This is taken from the same perspective. And we brought that stream up. In some cases, this was 10 to 15 feet deep, this gully. And we were able to raise it to what we think was probably the level, the elevation it was when the sewer line was installed. And again, you can see that system of riffles and pools that work their way down the system, converge, and then go off to Rock Creek, which is probably, I think, half a mile from where the confluence is. This is a photo looking upstream of the project. You can see in the background, that's the high school, Oregon Avenue. Again, there's a berm we created off to the right, and on the other side of that berm, a little ways, is the second tributary. This is right around where they come together and go off to Rock Creek proper. Just a couple of pretty photos of habitat. A lot of these systems, and if Bill were here, he could attest to it. Right after construction of this, the frogs moved in very quickly. There were neighbors that said they hadn't heard frogs before and were kind of astounded to hear the peepers and different species of frogs that made their way somehow. I don't know how that works, but I'm an engineer. Here's one of the grown-up frogs, again taken out there at Milkhouse Ford. Ducks have come in. There's a bunch of wildlife: ducks, frogs, dragonflies. Nick could probably talk a little bit more about what he sees out there too. Upcoming projects: we're doing an outfall restoration project in Rock Creek. This will hopefully be happening in 2020. We had to go we're following the NEPA process, but hopefully we'll just be able to use categorical exclusion and not have to do a full EA, saving time and money. So I actually walked a lot of these sites, or all the sites, with Bill and Nick, and we were able to identify sites that hopefully, we won't have to go through the extensive EA process. This is going out to bid soon, so we'll have contractors submit their bids for design. We're going to do it as design and construction to save time. And again, this is all Rock Creek Park. That's Rock Creek off to the right. I don't think is that, I'll ask Nick. That's not Pinehurst up top, is it? That's Rock Creek?
No, that's,
yeah. It's not showing that, but that's
another branch. It's a branch of Rock Creek.
Yeah, so another project we have coming up, and I didn't have a slide for this, is Pinehurst Branch, which is a 7,000 foot, when it enters the District of Columbia, it comes from Maryland, it's piped, and then comes out of an outfall on Western Avenue, and that goes directly to Rock Creek, about a mile and a half. And we're going to be working on a restoration project there. We're currently in the environmental assessment phase, going through NEPA compliance. That'll take probably 2 years, and once that's finished, again, like we're doing with the outfall projects, we're going to put that out for bid and have contractors, bid on that. That's it for Rock Creek. I just wanted to mention real quickly that we also have a similar relationship with National Capital Parks East. There's another stream restoration staff member here at DOEE, Josh Birch, and he's been working for years, as long as I've been working with Rock Creek. We've kind of just been assigned to different National Park Service properties. If he was here, he would be able to, and if we had time, he's got, I think, more projects than we've done in Rock Creek and National Capital Parks East. Again, we have a great relationship with that park as well. With that.
So one of the questions that we get quite a bit when we do our presentations is, since DOE doesn't own any land, how do we find our project sites? Well, you can see the number one bullet right there is enthusiastic landowners. So thanks to Park Service for all of your collaboration and cooperation and support throughout the years, because we couldn't do this without you. Sometimes our funding sources dictate where we can and cannot work. Again, like I said, because I'm a stormwater retrofit person, looking for large areas of untreated impervious cover that we can treat, and anything that's more impactful. So something closer to a stream, especially a paired stream, is something we're looking to work on. So the keys to success was one of the things we were asked to touch on, and I really think partnerships are essential in order to do that. And then we'll leave you just with a very beautiful stormwater photo. This is in front of our offices in NOMA in the district. This is a bioretention in action. So we can see that these things actually do work and make this a much prettier place. So with that, I think that's our presentation. Does anybody have any questions?
Yeah, well, thank you again.
Excuse me.
Yeah, go for it.
So we've gotten 3 questions so far. Seth, if you can take the first one. Cecilia, if you maybe take the second one, and I'll take the third one, and maybe we just repeat the question and then answer it. So Seth?
Sure. So the first question is, why was the decision made to just eliminate green infrastructure if standards aren't met? So I think that's going back to the flow diagram after the practicability analysis and post-construction monitoring on the first projects, the green infrastructure projects under the consent decree. And really the short answer is, we need to meet water quality standards, and we need to do that in a cost-effective way for district ratepayers. We can build all the green infrastructure we need to build, but we also really need to demonstrate that it's doing the job that it's supposed to do. And if we, can't demonstrate that for whatever reason, then we need to have an alternate plan so that we can ultimately meet the water quality standards that we need to meet under the consent decree. And maybe Cecilia or Stephen, you guys want to answer the SRC question, the next one?
I'm so sorry, I can't see the questions. Could someone read them to me?
Sure. It says, you mentioned SRCs.
That's the stormwater retention credit.
Private resources to implement stormwater retention BMPs to generate stormwater retention credits on a site like this that is a national park in DC?
Oh, well, that is a good question. So SRCs, again, stand for the Stormwater Retention Credit Trading Program that DOE offers. And I've got to say, full disclaimer, I am not an expert on our SRC program. I know that it exists, and I think it's awesome, but that's about the limits of my understanding. How you would generate SRCs on land that is not your own, I assume you'd have to have an agreement with the landowner that they would allow you to take those credits. But yeah, I think the idea is that you could privately finance stormwater management on someone else's land and own the credits as a result. That, again, is a question for Park Service. When we do voluntary retrofits on their land, we're not after credits. We're really after real-world water quality improvements.
Great, and as are we. But for folks who are interested in stormwater retention credits, our Water Resources Division in Colorado is working on those guidelines right now. So we should have more information shortly.
Very good.
Okay, so the third question here is, curious if some of this stormwater runoff remediation has factored in potential climate futures, i.e. increased storm intensities and frequencies, etc. So that's a question.
I'd be happy to take a stab at that from the district's perspective. I think this is a very hot topic right now. We are seeing a lot more frequent, intense storms, and we do design to historical data, right? Our standards today are based on however many years worth of data in the past. So it's a big challenge in a changing climate. How do we predict what those storm events, the 1.2-inch standard that I mentioned earlier is based on the fact that 90% of our annual storms, 90% of the storms that we get on an annual basis are 1.2 inches or less. So that's what that standard is based on. That number might be changing, so we need to figure out what is the appropriate number. I know a lot of folks are talking about this at the Chesapeake Bay program, and people are trying to wrap their heads around creating predictive models, and that's sort of the extent. I know internally, DOEE has talked about raising that number, but without that data, we're not doing anything about it right now.
So this is Carlton Ray. Basically, for the Clean Rivers project, we've oversized the tunnels as well as the conveyance system into the tunnels by 20%. So to get the flow into the tunnels, we've everything throughout the tunnel system. We've bumped up the sizes by 20%. We've also have a large pump station at the end of the tunnel system that we went ahead. There currently has capacity of 225 million gallons a day. We've already sized it and built the shafts and built the infrastructure so we can basically increase the pumping capacity from 225 MGD to 500 MGD. So basically for a little bit of money down the road, it's probably 1 or 2 generations from now, that they'll have the ability to install pumps that can pump up the flow at a much faster rate than where it's currently designed. And so, and then finally, if necessary down the road, we can also add additional green infrastructure. So climate change is real. It's certainly all the folks on this call certainly understand it. It's real. Like Cecilia said, the storms are getting more intense here in D.C. We had the wettest year on record last year in 2018, 66 inches of rainfall. So we need to be prepared, and we feel like we're in a good position to be moving forward on it. Is there another one?
Yeah, it looks like we got a couple others here coming in. So next question is, who is the best contact to further develop partnership opportunities like the ones accomplished at Rock Creek? Maybe hand that one over to DOEE.
Well, I suppose it's not straightforward enough, right? What type of partnership opportunities? Looking for opportunities to do green infrastructure on federal land, then the contact would be Park Service.
And this is Nick. I'm happy to talk to anybody on the service out there who wants to get more information about how we did this, the process and procedure and the planning. So feel free to contact me.
Yeah, and if there are other land managers on federal land within the district, and you have stormwater issues or stream issues, we'd love to hear from you as well.
Yeah, and this is Stephen. I do want to seriously say that, for 2 government agencies working together, we can do this fairly quickly. I mean, it's not as onerous as one might think with a federal and local government working together. These things can be accomplished. And
just similarly, this is Seth over at Clean Rivers. If anyone is interested in partnerships or opportunities with Clean Rivers, feel free to contact me as well.
And Nick, if you don't mind, I'm going to go ahead and enter your email into the chat box. So Park Service folks in the National Capital Region, if they want to learn more, they can, reach out to you and you can help direct them if you're okay with that.
Sure, thanks.
Great.
Okay, we've got one more question here. Is the visual portion of this presentation available for download or via a link? So maybe the moderator can answer that one.
Yes, again, this is Brian. Thanks for the visual portion. Download via, yes. So this, again, the webinar is being recorded, so it will be posted to our internal Connected Conservation toolkit that, I put a link to in the chat box, as well as the Park Service page on the Network for Landscape Conservation website, and that's an external facing site. And again, both links to both of those sites are in the chat box, and probably give us like a week or two to have those have the recording posted.
That looks like all the questions that we've received.
Well, fantastic, guys. I mean, you guys covered a lot of a lot of ground and had a lot of great information. It's just so timely, you know, for our folks and speaking on behalf of the Park Service to hear your message about green infrastructure. As you all have probably heard, or I'm sure the four of you already know, like the Park Service, we've got a big, you know, maintenance backlog. You hear Congress you know, talking about here and there, or it's in the, you know, in the news now and then as well. And you know, obviously, if we're going to rebuild some of these bridges and roads and parking areas, we want to try to make it better than it was. And so, you know, what you all have been able to do in DC with thinking about stormwater and the impacts to park resources and to the broader landscape is very timely and meaningful for the Park Service to hear. So Cecilia, Stephen, Seth, Carlton, thank you for all you are doing. And I want to leave one last opportunity for Nick, if you had any parting words for the group.
No, I think it's great that you're bringing all this information and all the projects that we've been able to accomplish together to, you know, a broader audience so they can see. And I welcome anybody who wishes to come to Rock Creek to see these projects. Feel free to contact me, and I'd happily be your guide.
Great.
Thank you so much, Brian.
Absolutely. And again, folks, there's a link there, email for Nick's contact information. And feel free to folks to reach out to me as well, and I can help direct you as well to the folks at DOEE and DC Water. And so with that, Cecilia, Stephen, Seth, Carlton, thank you again for a great presentation.
Thank you.
Thanks, everyone.
Thanks, everyone.
Take care.
Yay. Thanks, you guys.
Oh,
I know that was a heavy lift.
No, it wasn't bad, actually.
We started it a while ago, so it was fine. I had to give Bill Yeaman a shout out, though.
Yeah, no, I'm sure.